Hi, my name's Mary Kerr, and today I'm going to talk to you all about the unharnessed potential of a mimetic collagen peptide that we have found. Biochemists have been looking for a mimetic collagen peptide for a long time. Collagen is the most abundant protein in the body, and so having something that would act identically to collagen would be extremely useful in the medical field. Collagen exists in three primary hierarchical steps. And previously, other scientists have found mimetic peptides that exist in one of these stages, but prior to this finding, no one has found one that exists in all three stages at the same time, which is what makes this research so revolutionary. This discovery should come as a relief to everyone, as your own health might one day be positively affected by the results that we have found here. So where this peptide would be the most prevalent and the most useful would be in tissue regeneration techniques. The collagen fibril networks regulate and define most tissues within our body, and with additional research on this molecule, there's potential that it could actually be introduced into the human body and serve as a way to regenerate damaged tissues, not only revolutionizing the medical field, but also potentially generating millions, if not billions of dollars. Like I said earlier, collagen is the most abundant protein in the body, and it does exist in these three hierarchical steps simultaneously, these steps being peptide chains that form triple helices, which then pack to form nanofibers, and then nanofibers that interact to form hydrogels. So we hypothesized that earlier scientists had actually become extremely close to finding this mimetic peptide, but what they were missing was increased interactions between lysine and aspartate on the peptide's backbones, which we did here with our mimetic peptide. Like collagen, the peptide that we found also contains alternating proline, hydroxyproline, glycine repeating units, and salt bridges formed by hydrogen bonds. Here is the specific details of how we synthesize this molecule, and it's easy to get caught up in all of these details, but essentially know that it was created under specific conditions before being purified in order to chemically act as identically as possible to collagen. Right here is a picture graph that compares collagen within the body to this collagen mimetic peptide that we've synthesized, A being collagen within the body, B being this mimetic peptide, with the largest difference just coming in the difference of the peptide chain length as well as the triple helix length. And we did find that this was the case, that collagen tended to be much larger within the body, but this discrimination in length didn't affect the properties all that much. Like I said, the triple helices did form, and we confirmed this through circular dichromism experiments. And then we found that the higher the concentration of the peptides within our experiment, the more triple helices formed. And like I said, the length was the main difference. Also, we used different microscopy techniques to capture detailed photos of nanofiber networks that formed from the triple helices. And we did, in fact, confirm that they did form. In here, right here, I have listed the different dimensions of these. They were a bit shorter, but the properties of the nanofibers were not incredibly affected. And then lastly, a hydrogel did form through these interacting nanofibers, and it was compared both visually and then under different rheological and temperature thermal tests, and it was found to behave identically to collagen found within a rat's tail. So what's next for this experiment is that we need additional funding to see how this peptide would work upon being introduced in the body, and then more experiments need to be done to see how this the properties of this collagen mimetic peptide could be harnessed for tissue regeneration. And I know I said it once in the beginning, but it's worth repeating that this discovery is completely revolutionary within the medical field, and that if harnessed correctly and if research is done correctly, it has the opportunity to completely change healthcare as we know it. Right here are some sources from this presentation. If you have any questions, please don't hesitate to ask. Thank you.